Okay, and we're off to go ahead and start our next video. Chapter 19, guys. It is the last chapter of the semester. Woo! Okay, so I'm assuming you already watched my video about this, otherwise you wouldn't be doing the examples. These are chi-squared tests. There are two different kind of chi-squared tests. First, we're going to go over examples for goodness of fit. Then we're going to go over examples for the chi-squared test for independence, which are the two tests we could see in this particular class. Now, this is a goodness of fit test. How do I know? This is not a contingency table, right? So this is going to be a chi-squared, I'm going to call it a GOF, a goodness of fit test. Okay, so here's what we're going to do. In example 1, we want to talk about whether or not we are given a model or they're assuming that every value in the expected column is the same, okay, which would be a uniform model. So let's read. It says the number of books borrowed from a public library for a particular week are listed. Determine whether the number of books borrowed differs based on the day of the week. Okay, so they do not provide me, no model is provided. So we assume these are going to be distributed uniformly. Uniform distribution. Okay? A model being provided would be like a series of percentages. I think on Monday, 20% of the books are borrowed, but on Friday, when people get ready for the weekend, 40% of the books are borrowed. Hey, Dexter. And then that would change the model, right? But in this case, we're not given that kind of information. So we're going to have to figure out what we think would be a number of books borrowed that would be equal every day. And here's the deal. The first thing we're going to do is find the total in the observed column to really help us get started here. So if you add up all the values in the observed column, we end up getting 600. In order to discuss something uniform, we would take the total divided by the number of categories to figure out what would be our expected value here in each one of these columns. So this idea here is that no matter what I put in expected, the totals have to be identical, okay? So I would take my total, which is 600, and the number of categories in this example are the 5 days of the week, the weekdays listed. So if I try to figure out what goes in each one of these spots, it would be 120 books. So the expected number of books in order to reach the same total of 600 by the end of the week, our expectation here would be that we borrowed exactly 120 books each day. Okay, so now the question is, determine whether the number of books borrowed differs based on the day of the week. So in order to do this, we want to write out our null and alternative hypotheses. And if you recall, these hypotheses are actually in words. So what we're going to do here is talk about whether or not the particular variable we're studying does follow the given model or does not follow the given model. So it would be like in this case, the distribution of books borrowed does, right, follow, or let's say follows the distribution of books borrowed. I've already lost my language that I like to give you. Follows the given distribution or is distributed. Oh my goodness, what's wrong with me, guys? Let me find my notes. I want to make sure I use the same exact thing that I told you to use in your notes. And for some reason, I'm drawing a total blank. It says the is consistent. My goodness. The distribution of books borrowed is consistent with the model. Okay? So then remember, this is the chi-squared for goodness of fit. Our null hypothesis says it is a good fit, and our alternative hypothesis is supposed to say it's not a good fit. So here we'd say the distribution of books borrowed is not consistent with the model. Okay, so now all of us have the same first step, minus our total. So I'm going to put a thicker line here. We do not put our total in the calculator. Okay, all of us put observed into list 1 and expected into list 2. And then the lucky ones of us will go and run our chi-squared GOF test under stat, arrowing to test, and arrowing all the way to the bottom of your list. If you are an old calculator person who does not have this test, I will make an additional video to help you with this problem. And then you can apply that same logic to help you with example 2. Old calculator people that don't have the GOF test. This is the one thing I mentioned on day 1 that would put you at a disadvantage in unit 3. But since we no longer have only a note card to write on, you can write down the explicit steps if this is going to be on the unit 3 exam. All right, so if you go ahead and run your chi-squared test, whether you're doing it the long way and watching the other video, or you're doing it with me, right? Chi-squared is equal to 4.517, and my p-value is 0.341. I didn't provide an alpha level, which is just wonderful. So let's go ahead and use alpha equals 0.05. Sorry about that, guys. And if we look at the p-value versus alpha, it's definitely larger, which means we would fail to reject the null. So this is a tricky statement because our alternative hypothesis has a negation in it, and so does the wording in terms of writing a failure to reject. So there's a double negative in this sentence, which is a little bit tricky, but I just want to make sure it makes a little bit of sense to you. So there is not enough evidence to show, and then we're going to repeat the alternative because it's already written in words. The distribution of books borrowed, sorry, I know this is getting really low on the screen, is not consistent with the model. Oops, let's move this over because I know there's like a doceri thing with the model. Okay, so there's not enough evidence to show the distribution of books borrowed is not consistent with the model. What I'm basically saying is I could not show that the books differ based on the day of the week, right? These numbers are too close to 120 to say that they're any different from one another. All right? Now, remember, we can tell that each day of the week, these numbers are not equivalent to 120. So that is a little bit of a throw off. But we're just checking, is this model appropriate or not? And apparently it is. All right. Second video will be example 2 on the right below on the same page.